Hi everyone, in today's video we are going to study another kind of document, that is system design specification. Now this document, which is known by the name of system design specification or also known by the name of software design specification, has a primary audience, that is the system implementer or coder. So by primary audience I mean the people who primarily use this document known as the system design specification or software design specification is primarily used by the coders or programmers, who we also refer to as system implementers. The system design specification gives a complete understanding of the details of each component of the system and its associated algorithms. So basically we know a system is divided into various subsystems or modules, so that this complexity of the system reduces and the understandability increases, because the programmers or the implementers who will be implementing them in the code should be able to understand it very well. So for that reason a system is divided into modules, which is also known as components. So when a system is divided into several components, each component is much easier to understand than the system as a whole, and then its associated algorithms are also given or defined properly in the system design specification. So two major things which are required for a programmer: first of all, what all the modules or components of the system would be, and what would be the logic behind those modules, that means what would be the associated algorithms. So the system design specification gives these two things in detail: the components of the system and their associated algorithms. So once a programmer knows what are the modules or components of the system and what is their associated algorithms, it is very easy for them to implement in a specified coding language. So that is why we say that the programmers or implementers are the primary audience of the system design specification. Now the system design specification consists of the final steps of describing the system in detail before the coding starts. So before the actual coding can start, everything is designed and defined on paper very well, so that coding becomes easier, implementation becomes easier. So this system design specification consists of all those final steps which design and describe the system in detail. The system design specification is developed in a two-stage process. Now this document, known by the name of system design specification, is developed in two stages, hence a two-stage process. In the first step, design specification specifies the overall architecture of the system at a higher level. So in a generic way, at the higher level, the overall architecture of the system is specified in the first step. Then in the second step, it provides the technicalities or the technical details of the low level design, that means the components which will guide the implementer. What are the tools for describing the systems, describing the design in a system design specification? So the tools that are used for describing the design in a system design specification are, first of all, data dictionary. Now if you have studied DBMS or database management system, you must be knowing what a data dictionary is. This is a very important tool for designing the system design, for giving the system design specifications. In data dictionary, complete definition of each data item and its synonyms are included. A data dictionary may consist of description of data elements and definition of tables. Say for example, you have various entities, like if you are making an application software for a college. Now college will have several entities like faculties, it may have students, then the administrative staff. So what these are the entities. So if I say faculty, I say faculty department wise, faculty computer science. So faculty computer science is a name given for the data item. It may have a synonym such as FCS, right? So all the names of the data items, and if there are any synonyms, that they are also given in the data dictionary. It also gives a description of the data elements. For example, the data element is faculty computer science. The description for that would be given in the data dictionary, which would tell that this is for the faculties. This describes the faculties who would be teaching courses in who would be taking classes in the computer science course. So, the data entities, their synonyms if they exist, and the descriptions about those data entities, that means what are those data entities doing here, would be given in the data dictionary. So, while we were talking about data dictionary, we said basically it consists of the description of data elements. Now, description of data elements means whatever data is being used, say for example, the variables, basically the variables that we used in the application software, like the faculty computer science, faculty HR, faculty mechanical, faculty electronics, these are all data elements, right? And they may have some aliases also. Like I said, for faculty computer science you can use a alias or synonym FCS as a short term. So, all the names and aliases of data items are described while giving the description of data elements. Uses, which processes or modules use the data item, how and when the data item is used. This is also described in the data dictionary while describing the data elements. What are the standard formats for representing data? Additional information such as what would be the default values, like the default value of a student phone number can be blank. It is not necessary that all the students may have phone numbers, but the default value of a student address cannot be left blank, because each student will have a residing address. So, we use this kind of additional information is also given as to what the default values for the various data items can be. Initial values, what would be the initial values of the data items if they are not provided? What are the limitations and constraints that are associated with the data elements? So, all these things are given while describing the data elements in a data dictionary. Now, while you describe the tables, or when you give the data table definitions in a data dictionary, so what all things do you define? You define the table name and aliases. Now, all those data elements or data items are stored in their relevant tables. For example, the details about faculties would be stored in the faculty table, the details about the students would be stored in the student table. So, that means you will have to give a relevant table names also and aliases also if you are giving any. Then, who are the table owners, or what are the database name in which those tables are stored are given in the table definition. Key order for all the tables, primary key and foreign key. We all know the tables are run by primary key and foreign keys. In most of the cases there will be tables, there will be no tables without any primary key. Every table will have a primary key. Primary key is basically that key which is uniquely identifying a data element from all other data elements, or a data item from all other data items. For example, if we talk of a student table, in the student table each data item, that is the student, is uniquely identified from the other data item using the roll number. In a class, two students may have the same names or some same other details, but no two students will have the same roll number. So, that means it is the student roll number which is uniquely identifying the student from the other student in the class. So, in that case, for a student table, the student roll number would be the primary key which is uniquely identifying the student from rest of the students. So, the key order for all the tables would be given using the primary key and foreign key is basically that key which is primary key in one table, but then it is used as a key in used in another table. So, in that table it becomes a foreign key. For example, as I told you, roll number, student roll number would be the primary key in the student table, but when this student roll number is used as a data item in the course table, I am sorry. So, when the student roll number in the student table would be the primary key, but when the same student roll number is used in the course table where it is not the primary key, but since it is a primary key somewhere else, so that means it would be the foreign key in the course table. So, that way giving order for all the tables which includes the primary key and foreign key is given in the table definition. Also information about indexes that exist on the table. In table you sort out information using indexes, just like you use indexing for finding out information in your books. So do you find information on the table using indexes, like you can do sorting roll number wise, or you can do sorting course wise. So information about the indexes is also given in the data dictionary while giving table definitions. Now these first tool, as I told you, was data dictionary for giving the system design specification. The other tool for designing the system design specification is the database schema. Now basically schema is a graphical presentation of the whole database. So basically how the entire database would look in general is provided by the schema in a graphical or pictorial manner. The data retrieval is made possible by connecting various tables through keys. Using the schema you can find out which is a foreign key, which is a primary key, how two tables are connected. In a database it is very important that all the tables are connected to each other logically. And how are they connected? They are connected with the help of primary key and foreign keys. So you can retrieve data between two tables only if they are connected through primary key and foreign keys. So this is what it is saying, that the data retrieval is made possible by connecting various tables through keys. Then the next design tool for the system design specification document is your ER model. The ER model, its full form is entity relationship model, and it is a database analysis and design tool. So basically it is a tool which is used for the analysis and design of databases. It lists out various real life application entities and defines the relationship between the real life entities that are to be mapped to the database. So basically a database revolves around all the real life entities. Say for example, if you want to make an application software for your college, that means you are targeting all the real life entities. All the faculties are the real life entities, all the students are the real life entities. So what all the real life entities or real life objects in that particular database would be, that is listed out by the ER model. It is with the help of ER model that you figure out, okay, these are all the real life objects or entities that would be included in the database, and then since they belong to the same database, they must be logically connected to each other. So that means the relationship between those real life entities will also be shown, that how they are mapped to the database. For example, faculty is one real life entity of the database and student is another real life entity of the database. Now they cannot exist without any coexist without any relationship in the database. Both the faculties and students are logically related to each other. Faculty is teaching the students and students are being taught by the faculties. If there are no students, faculties won't be able to teach. If there are no faculties, students won't be able to study. So there needs to be a relationship among all the entities of the database in which they would be coexisting. They need to be logically related to each other, and again how do you relate them? With the help of primary key and foreign key. Then the fourth tool is the security model. The security model, database security model, basically associates the users, the group of users or applications with the database access rights. That means who will be having what right to the database. That this is all taken care of by the database security model, that which all users or which all group of users or which all applications can have database access rights and what type of access rights. Then the another tool is your trade-off matrix. A trade-off matrix is a matrix that is used to describe decision criteria and relative importance of each decision criteria. So all the decision criteria are described using the trade-off matrix, and what is the relative importance of each decision criteria is also described using the trade-off matrix. Basically this allows comparison of each alternative in a quantifiable term. Now to solve a particular problem, you can come up with various decisions, and out of all those available decisions, which one would be the most optimal, this comparison is provided with the help of a trade-off matrix. Another tool is your decision table. Now, this decision table shows the way the system handles input conditions and subsequent actions on the event. So, whatever the input conditions are, and based on those input conditions, what are the subsequent actions on those input conditions, and on the basis of those actions, what events occur, all this is shown by the decision tables. A decision table is composed of rows and columns. So, just like any table, a decision table is also composed of rows and columns. You have rows, you have columns, and these rows and columns are separated into 4 separate quadrants. So, just like here you can see there are 2 rows, there are 2 columns, and they are then separated into 4 separate quadrants. So, you can see 1, 2, 3, 4, there are 4 separate quadrants. In one quadrant you show the input conditions, all the possible input conditions. Then in the second quadrant you show the condition alternatives, what all condition alternatives are there. Then you show the actions that are taken on the input conditions, and based on the actions taken on the input conditions, what are the subsequent action entries or events. This is all shown using the decision table, using this kind of a 4 quadrant table. The another tool is your timing diagram. Now, this timing diagram describes the timing relationship among various components and the behaviors of each component. So, it shows the as per the timing, what are the behaviors of the components, what are the relationship among these components. This is shown according to the timing diagram. Basically, they are used to explore the behaviors of one or more objects throughout a given period of time. Now, as per the action taken, the behavior of the objects would change over a period of time. So, this timing diagram depicts that only, that okay, initially what was the behavior of this particular object, when an action was taken, what was the behavior of this object. So, with the passage of time, throughout a given period of time, what is the behavior of each and every object is explored using the timing diagram. Then is your state machine diagram. This is another very important tool for designing this system design specification. This tool, that is the state machine diagrams, are very good at exploring detailed transitions between states as the result of events. So, an object would initially be at a different stage, and then when some action is taken on it, so it would transition from one state to another state, leading to different events. So, these transitions are basically depicted with the help of state machine diagram. So, you in a system you start, there is a start stage or initial state, then some action is taken, then because of the result of that action it goes into state 1, then because of some other actions taken on it, it goes into state 2. It's like you log in into the system or you log out of the system. So, all these actions or events lead to a change in the state of the object. So, these transitions are depicted using the state machine diagram. As here you can see, the figure here is depicting a state machine diagram wherein you initially started, then you were in an active mode which led to state 1, and then on coming on state 1 you log in and then you log out of the system, which leads you to, when you log in into the system from state 1 you reach to state 2, then again when you log out of the system you go back from state 2 to state 1. So, this is how the transition between these states is depicted over using a state machine diagram. Then another interesting tool for this system design specification is the object interaction diagram. The object interaction diagram illustrates the interaction between various objects of an object oriented system. Wherever we are studying object oriented systems, wherein the systems are specified in terms of objects and classes, the interaction between the objects is illustrated using an object interaction diagram. This diagram consists of directed lines between clients and servers. So, basically the objects here are the clients and server, and as you know, clients and servers interact with each other in a request and response mode. So, how is the interaction between the clients and servers, which are the objects, depicted using direct lines? Each box contains the name of the object. So, how are the objects represented? Using a box which would contain the name of the objects, and the vertical distance is used to show the life of an object. The length of the vertical distance basically shows you how long an object will live. Here you can see an object interaction diagram. For example, message 1, message 2, these are the interactions between the objects, return, return. So, object class 1, object class 2, object class 3, classes are represented as objects in a box. So, as many classes will you have, so will be the number of the boxes. Say for example, here there are 3 classes, so 3 boxes for 3 classes, and the interaction between those classes through messages and return messages, and the length of the object, that particular object is depicted through these lines. So, this is your object interaction diagram. The flow chart is another important tool. The flow chart is another important tool that is used for a system design specification document. Flow chart you must have all started in the beginning also when you started C programming, because you always start programming with algorithms and flow charts. You never jump onto the code immediately. So, you start with flow charts and algorithms. So, I am sure many of you must have started flow charts, but basically what is the flow chart? It shows the flow of processing control as the program executes. So, how the flow of data would be, what all data would come first, the processing, and all these things are depicted using a flow chart. You can see a sample flow chart example over here. This is how a flow chart looks like. You start, then you give the inputs, then you do the processing of those inputs, then the output is given, and then you end. For say for example, if you want to add 2 numbers, you want to add 2 numbers A and B whose value are 2 and 4 respectively. So, if you want to depict this through a flow chart, you will always start with the start tag. After that, you need to input some values which have to be added. So, those values would be like 2 and 4, right. These are the 2 values that have to be added. So, they are the input here. Then the processing has to be done. That means the addition you will do, that is the processing. So, 2 plus 4 which gives you 6 is the processing here, and then 6 is the output. So, output is like this written here, and then finally when you have got your desired output, you end it. So, this is how the flow chart works. It shows the flow of the events and it shows the flow of the processing control as the program executes. So, this is how a flow chart looks like. Next important tool is your inheritance diagram in any system design specification document. The inheritance diagram is a design diagram that primarily documents the inheritance relationship between classes and interfaces in an object oriented modeling. Now, in any object oriented architecture, you have classes and objects, and there is a concept of inheritance. That means objects inherit the properties of their classes, just like you inherit the properties of your family. You have a nose like your father, you have eyes like your mother, you behave like your mother, or you behave like your grandfather. So, you have inherited from your family. Similarly, the objects inherit things from the classes that they belong to. So, this property of inheritance is depicted using the inheritance diagram. The standard notation consists of one box for each class. So, each class is represented or depicted using one class. The boxes are arranged in a hierarchical tree according to their inheritance characteristics. So, what is the hierarchy of the inheritance characteristics? The boxes are arranged in that hierarchical manner. Here you can see the objects are represented using the boxes. As I said, the boxes are arranged in a hierarchical tree, and each class, there is a box for each class. So, these are all the classes, and the boxes are for the classes. Now, it is in a hierarchical structure as per what is the hierarchy. Like for example, if you look at your family tree, in the hierarchy your grandfather comes first, or your grandparents come first, then comes your father, because your father has inherited from your grandfather, and then comes you or your siblings, because you have inherited from your father. So, this is the hierarchy of inheritance. Similarly, in object oriented paradigm also, classes are represented using objects, and they are written in a manner in the order of hierarchy. Say for example, this is a typical inheritance diagram wherein you have objects, then you have classes. This is a class, this is a class. So, for example, this is a bank. Then bank will have two kinds of classes, account and client. There needs to be account, there needs to be client. Account will have further saving account and current account. Clients will be corporate account and individual accounts. Now, with the saving account and the current accounts are the specializations of the account, but in general they will have the general properties of the account. They will have an account number, they will have a customer ID, they will have the bank address. Similarly, clients are separated into these two categories, corporate and individual clients, but they have these similar properties of the clients. That means they have a client name, client address, client ID. So they may be specialized, but they inherit the general properties of the classes to which they belong. So saving account or current account will have some general properties of the account class. Similarly, corporate client or an individual client will have the general properties of a client. So this is the inheritance diagram. Then is your aggregation diagram. Aggregation diagram basically is used as an advancement over the ER model. ER model tells you about what all the entities are, what their attributes are, and what is the relationship between those entities. But the ER model cannot express relationship among the relationships. So to overcome this, we use the aggregation diagrams, which shows the relationships among the objects or relationships among the relationship. When a class is formed as a collection of other classes, it is called aggregation. You have one class, you understand what a class is. But when a class is formed as a result of the collection of other classes, this particular thing is called aggregation, and this relationship is depicted using the aggregation relationship between diagram, which shows the relationship between various classes. Now, the relationship will be indicated by a direct line from container to container. Container to container means from box to box, which are used to represent the classes. So, a direct line between these two classes will show the relationship among those two classes. Here, for example, you can see the example of an aggregation diagram. There is a center, there is a course, and there is a visitor. Center is a class, course is a class, visitor is a class. You can very well show the relationship between center and course, but to show the relationship between this center and a course, which together becomes a class. And now, what is the relationship between the center, course and the visitor? You can depict relationship between center or visitor, you can show relationship between course or visitor, you can show relationship between center and course in an ER diagram. But as I said, it becomes difficult to show the relationship between classes when a class is formed as a collection of other classes. So, this was one class, center was one class, course was another class. Now, together after a relationship has been formed among them, they become one more class. This together becomes one class, which is a collection of classes. Now, this particular class enclosed in this box, this box encloses two classes, center and course. So, this box, which is another class now, is a collection of classes which is center and course. So, it is difficult to represent the relationship between collection of classes and another class, but this is done using aggregation. So, what is the relationship between this particular class and this class visitor? That the visitor inquires for this class. That means the visitor inquires for all the courses that a center offers. So, this is represented using an aggregation diagram. Then is your structure chart, another very important tool for a system design specification document. A structure chart is a tree of subroutines in a program. So, basically a tree structure which represents the subroutines in a program. As you know, a program is divided into subprograms or modules. So, subroutine is basically a function or a procedure, just like you divide a program into various functions, so that whenever a code needs to be repeated, it is written in a function. Instead of writing it separately in each and every module, what you do is that you make a separate module and write that piece of code in a module. So, whenever any other module requires that particular piece of code, it will call that module, and that module, which will be called repeatedly by several other modules, is called the function or a subroutine. So, it makes code reusable and readable. You do not have to write the same piece of code again and again. It is reusable. It can be used by other modules and it is readable. Since it is in a divided into a module, it is easier to understand and read. The subroutines should be labeled with the same name used in the pseudocode. So, whatever name you have given to the subroutines or the functions in the pseudocode, you should use the same name while programming also, to avoid any confusion. So, this is how a structured chart looks like. A system, you know, system to reduce the complexity and understandability is divided into subsystems or modules. So, this system is divided into subsystem A and subsystem B. Then this subsystem A is divided into program A1, program A2, program A3. These are the 3 subroutines or modules. Then subsystem B is also divided into program B1 and B2. These are the subroutines or modules. So, this is a structure chart. Then the another most important tool is the pseudocode. Pseudocode is a kind of structured English, as the name itself says, pseudocode. Pseudo means which is not which looks like a code, but which is not actually a code. So, it is a kind of structured English for describing algorithms in an easily readable and modular form. Some people confuse it for algorithms also, but these are not algorithms, these are pseudo codes which include half code and half English language. It allows the designer to focus on the logic of the algorithm without being distracted by the details of the language syntax in which the code is going to be written. So, basically the focus here is to find out or figure out what the logic of the associated module would be, without worrying about which language it would be written into it. Once you are clear with the logic, for a programmer it is very easy to implement it in whichever programming language it has to be implemented, if he is well aware about what the logic is. So, this very logic is provided by the pseudo code. It describes the entire logic of the algorithm, so that implementation becomes a routine mechanical task of translating line by line into source code of the target language. So, this is how a pseudocode looks like. So, if, like for example, you want to make a program wherein you want to tell if the maximum working hours are more than this, then you will display overtime, and if the maximum working times are equal or less than this, then you will display regular time message. So, how would you write this in a pseudocode? Something like this: if hours worked is greater than max works hour, then display overtime message, else display regular time message, and end if. So, basically it is including codes in the form of if, else and then, and it is also including English language like this. So, it is a mixture of English language and code and the coding language, hence it is known as pseudocode. Unlike algorithms, it is not pure English language, and unlike programs, it is not pure code. It is a mixture of code and English language, hence it is known as a pseudocode. Now, let us look at, we have seen all the tools that are used to design a system design specification. Now, let us look at the contents of a typical system design specification document. How a typical system design specification document looks like. It will consist of the introduction part. Introduction part basically tells you what the purpose and scope of this document is, what are the various definitions and acronyms, and what are the abbreviations and references used in this particular document. The second point would tell you about the system architecture description. So, system architecture description, since we are talking about software, so what would be the architecture be? It would be the various modules. So, it will give you the various overview of the various modules or the components of the systems and various subsystems that exist, also the structure and the relationships that are existing in this particular system. Then it will also give you a detailed description of various components. Now, overview of modules is given. In the third step, a detailed description of all the modules or components would be given, and in the fourth step, the appendices would be given. So, this is all about your system design specification document.